Hi everyone. Thank you for coming to my talk at Civo Navigate. Today we will talk about something cool, something emerging, that is about CDEs, which is like cloud development environments. So before I start, a bit about me. I'm Hrittik Roy. I'm a platform advocate at Loft Labs, and I'm a CNCF ambassador as well. So this is my first time at Civo Navigate, and second time in Germany because I was there at Container Days as well. So, a question I have for you is um, how many of you have felt this when you have a project you want to work on, but your office laptop is kind of tricky? Raise of hands, only one person, two, three, oh, a lot of you. And it is a very common problem because hardware is kind of outdated by the time we are using new technologies. So there are new chips, there are new projects, there are so many things that are coming new every time. So every time the problem is our hardware is going slower, and that is a problem. But that is not just one of the problems that we face as a developer. So there are another problems like whenever there is a new team member coming in, there must be some wiki or something where they can learn and configure all the things they want in their environments. Generally, you can have some Docker manifest and everything, but repeatability is a problem because there is no specific configuration which defines how your environment should be. There are steps for sure, but there is not a one-click option so which can define how your environment can be. The next problem is isolation. So there might be a case where you're running different languages, different version of the languages, different dependencies. So there might be no isolation between them. And because you are working on different projects in different teams inside a company, that can cause issues because you need to again clean or create a environment, a virtual environment. But again, virtual environment is restricted to language. Suppose you have some more high level tools that you want to have isolated. That is not possible. Next is managing those dependencies and versions of different tools and your dependencies. That also becomes complicated as you are moving on different versions. If you are suppose moving your code base from a version to another version, so you need to test those out and all those. Next is portability. Suppose you are using something on your local machine and now you want all of those tools to be on cloud because you want to use the new GPU that is there or a new TPU. That can be challenging because you need to go and configure all of those things again. So there is no portability as simple as that. And last, it's like cloud power. You might require more power than your normal machine can take. So you need some more hardware. The traditional way is to go and ask your manager for approval for the new upgrade, but that can be time consuming because you might work on different projects at different time. So that is a bit challenging. But all of those boils down to one central thing. The developer experience is not up to the mark. So whenever you're trying to build something, there is a bit of challenge in between because if you're working on a simple project at a simple time, it is as smooth as it gets. But when you're doing a lot more things in a cross-functional team, that is a challenge. So to understand what can be a solution, we need to go back a bit before to understand what is infrastructure as a code. So what we learn from infrastructure as a code is like, it is self-documenting. So if you have a file, it documents how your infrastructure will be. It doesn't get stale like a wiki page. That means you don't need to go and update documentation ever you're changing your infra. You can just update your configuration, and that is good enough. And whenever you have a new infra, like a new staging environment or a new testing environment, you can just apply those configuration again to create one with different secrets and all. But the general theme is it can be as simple as that. So Microsoft thought about this, and then they created, after they created so many of the tools, they thought to do something about this. And then there comes the concept of dev containers. So dev containers, as we can see, is like some development containers, but it is most of a standard. So dev containers, JSON is a standard which can define how your workspace can be. And it is a lot of things in that. So we will just break down a couple of them. So first of all, it defines a workspace, like what languages you want in it and what configuration you want in it. Second is, it is an open source specification, so you can just go and modify it. And it was just, as discussed, released by Microsoft. So if you just see the sample, we will have a simpler sample later on. But here we are using a Python base image with a couple of spell checker extensions, and we are forwarding the port so that whenever our developer creates this environment using this configuration, they will have a Python 3.1 configuration with the spell checker extension, and it will just go and run the requirements.txt so that they have a working environment. So what does exactly dev container focuses on? So whenever we try to create containers, our main goal is to make it as minimal as possible because we want that to be done in production environments. So secure images, secure base images, as well as focusing on minimalizing it so that there is no extra dependencies and it just is the as minimal size as is required. But dev containers goes in a different logic. So generally there are three layers. One is what you have a minimal image, that is your deployment layer. But there are two more layers which dev container specifically focuses on. One is the inner layer, so where your inner loop needs, and there is the outer loop needs. So the base is you don't have a compiled code, you have your source code only. And then you can have your debuggers, all your extensions, all your SDKs, libraries, everything. So it's not a minimal image, but it's the opposite of that. You have everything you need to build an application or build applications. So that is it. So whenever you create a dev container, you will have all of those requirements so that you can just build things instead of just produce. So next is, how can we have a simplest dev container example? So here's a very simple dev container example. So where we are using a Go application, and the base image is 1.20 bullseye. And then whenever we are using this, we have a pre-built repository. So your pre-builds will have all of this thing already compiled. So whenever your developer is there, they will have a repository which has, will have a workspace which has this pre-built, so they can just go and use it without even focusing on how to install Go, how to install the dependencies or anything. This is as simple as it gets. So later on we will see a demo on how we can do this as well. But the question is, it's great that you have dev containers. It's great that it can configure everything you want to, but how to use them? So there are a couple of options. There is GitHub code spaces. So code spaces focus on, it's a non-OSS version, so it focuses on how you can have workspace running on their environments, but it might be problematic for compliance reasons. So what we did at Loft is we launched something on our own last year. So we launched Depod. So it's a CLI tool, and it can be a desktop application as well, which you can go and download. And it is open source, so we have around, we'll go later on that, and it's client only. So what I mean by client only is, once we have released in OSS in 2023 May, we were quite popular, and there was a requirement of people to have their own workspaces running on their own environments. So a lot of people came in, and we got a lot of traction then. So right now, last time I checked, it was like 8,600 stars. And then people wanted to create more workspaces over here. So generally, if we want to summarize what workspaces are your machine, like your environment where you are running certain things. Suppose if you have a backend of some Python version and some dependencies, so your workspaces is that. So it runs in a container, and it can run anywhere you want. And it holds all your inner and outer loops, and it can start and stop whenever you want to. And what can you have in your source code? So your source code can have your Git repositories, your commits, your branch, your subfolders, your local folders, as well as your images, your Docker images. So you can technically run your Depod anywhere you want to and pull anything you want to. And the providers, So providers are where your environment is running. So with code spaces, your environment runs on Microsoft Cloud, Azure, which GitHub has tied with it. But with Depod, you can run your infra wherever you want. So what we support is a couple of configurations. Like you can run your environment in your local Docker, in any Kubernetes cluster, using SSH or using clouds. Like you can use the Civo cloud. So whenever you use this, what Depod does is it goes and creates a machine over there and then creates containers. And then you can reuse the machine for other containers. But that is how you use your workspaces. But apart from that, there are more providers. So providers are OSs. So you can contribute as well. So we have so many community providers like OVH Cloud and Equinix, where you can just configure your provider or create one for your specific infra, and then you can run your workspace over there. So for example, if you have a use case of GPU sharing, you can create a provider, and then you can have your Depods running over there. And whenever there is a new researcher coming into the picture who wants an infra with AI infra enabled, they can just request a Depod from your team, a workspace, and they can run it without even worrying about configuration and all those. And this is just possible because of dev containers as well as Depod. Going back is like, how is the process of provisioning a workspace? So we talked about what is Depod. What is dev container? Dev container is a standard, like your YAML is standard, but it's a JSON one. And Depod is a tool which helps you to do that. But how can you combine both of them? So the first process is to initialize your provider. So as we go back, providers are where your environment is running, which can be anywhere you want to. So you should initialize a provider. Then depending upon your provider is a machine provider or a non-machine provider. So in machine provider, you launch a machine, a VM over there, and then create a workspace in it. In a non-machine provider, like in Kubernetes, if you use your Kubernetes clusters, they will create a container over there only. And then it will create and ramp a workspace over there, and then connect that with your IDE. So we offer a lot of IDEs, like you can use VS Code, JetBrains, Jupyter Notebook, and all of those. And then they have a such remote connection with the main machine to your IDE. And suppose you are working on some web development stuff, you can also port forward from your local VS Code from the remote, so you can use the UI as well. For example, if you are just using a Kubernetes dashboard, for example, the port forwarding is also there. Next is use cases. So how can we use this? But before that, anyone has any questions before we go to use cases? No questions? Great. So, yeah. So generally, use cases is like whenever you are going to CD, like going to the CD approach, you might try to do it with your own VM. But the problem with that is it's more expensive and you need to manage all the infra. So first of all, if you use an open source tool and if it's something you are managing on your own, there's a lot of cost saving. But apart from that, one of the most popular use cases we get is onboarding your new developers. So suppose if you have an open source project and whenever there is a new developer coming in who wants to contribute to it, they need to go through all the documentation and create issues to understand what is happening wrong. So if you have a standard which defines everything on its own, and whenever just they go and click with open with Depod, it runs and ramps up an environment for them that is smoother for them as well, because they can just worry about the code and how they can improve the project instead of focusing on the infra layer. Next is cloud power. The second use case which we are getting a lot is a lot of AI researchers and a lot of engineers want more power in their systems. So you can just configure a Depod using a dev container JSON to use any of the clouds you have and use the standard billing discounts as well to get them a more powerful machine so that whenever they are using that, they can get their works done easier. Last is better developer experience. When you have defined everything together, and you have defined all your workspace, all the extension that your team needs to run a certain thing, it improves the developer experience because they just need to go and click a couple of things. And it can be a tech and non-tech person even. For example, if your sales team wants to try out a new feature in their demo, they don't need to just go and configure everything on their own and ping you on the engineering Slack. You can just automate this so that anyone in the team or anyone outside the team who's just trying out your project can do this very easily. Now, last is how can you use Depod right now? So you need to go to depod.sh and download the Depod CLI or the app, whatever you like. And then you can add your Civo or Kubernetes provider. And then you can just easily launch dev containers. So I've just recorded a simple demo for this. So before that, there's a QR if you want to go to depod.sh, and it is Depod, the same spelling, .sh if you want to type that thing on your device. I will wait a couple of seconds over here. I think all is good. Yeah. So let's try the live demo because we have some time. If not, we will just head back to recording. So if you see, we have a couple of providers already enabled. One of them is a Civo provider. And we can define like the region, the space, and all those things over here. And the other thing you can do is like, you can also create a Kubernetes cluster and then use its context over here. So you can run your containers, your dev containers over there. So for sake of simplicity, we'll just go with the Civo provider, which what does is like, it just creates a machine in your environment, and then it runs it on the Civo cloud. So you can just go and click on create workspace, and then there are a couple of sample applications which we can choose. We'll just choose maybe Python, and the provider will be same. And then you have an option to choose any IDE you want. The IDE list is constantly expanding, but for simplicity, we'll just choose VS Code over here. And then you can put a name over there if you want, and like Civo. And then you can have pre-builds as well. So right now, when we run this, you will see this is a long process because we are creating a machine, configuring it, and then launching it. But what pre-build does is it caches all of that. So whenever you go, you can just run a mission as simple as that, and then just go and click create workspace. So what it is doing right now is it is going and creating a machine called Depod shared Civo. So machine is like a virtual machine. And then it will do a couple of things. First is we'll wait till the machine is provisioned, and then it will inject itself to it. And after injecting, it will download all the dependencies like Docker, because we need a workspace over there. So let's wait till it happens, because it will take a couple of minutes. And yeah. Till then, if anyone has any question or answers, yeah, sure.
From this interface, can you install more software to these containers?
Can you give me an example of software?
Let's say I'm building software with Go, but I need to have kubectl and
Yeah.
some other things there.
Yeah, that can be done. Let me just show you how. So what we are doing is we are creating templates right now. So I think this one. Yeah. So for example, I want a kubectl with me, and I can just configure it to install this when we are creating the dev container. So it can be easily done. Like you just need to configure everything, and the important part is only one configuration is good enough. Once you have configured and created everything, anyone from your team can just reproduce it by just clicking like open in Depod button or just adding that script. So let's, so right now as we see, it is injecting and trying to run. There's a port forward. The Depod daemon is being installed into the server. So we'll need a bit more time because once the daemon is, yeah.
You have this diagram where it was Depod at the start and then production at the end. So I've used Depod a couple of times, code spaces, etc. But I'm wondering how you set it up to make it easy to go to that production stage from the dev container, or is that sort of a different step?
Which diagram?
It was sort of like on the top was yellow saying dev container. This one, yeah.
Oh, so this is a differentiation diagram. So this is dev container, and that is production container.
It's like current, this the continuation of the green on the top.
Yeah, that is like you will need your OS runtime in any container you run, right?
Yeah.
So that is the
Packages or something in there though, and
yeah.
libraries or shared libraries.
Yeah, so that will be required for you to run your production container as well, right? Like if you're compiling, that's another thing. But just if you're running some small production container.
You define this level in the
No, we just define the first two levels. Third one is not defined. Third one is different. So this diagram is just a contrast between what you do in a production container and what you do in a dev container. In dev container, you just put everything you want in it. No optimization and stuff. In production, you do a lot more things. So right now we are pulling the layers. It will take some more time. And this time is because we are provisioning a machine, injecting ourselves into it, and then configuring. So if we have a pre-build, this is already cached, and it takes lesser time. So let's wait. Till then, I am open for questions. Please.
On the same configuration roles, how do you deal with access?
So like access of the user.
How do you deal with, for instance, being able to pull a current repository into the DevPod?
Yeah, so what we do is, Depod is local, right? We sync your configuration. So you have an option to sync your configuration while just pulling, or sync your configuration to your workspace. So you can configure that. So when you sync your configuration just for pulling, it just use your credentials to pull, like a Git clone, nothing else. But if you sync your configuration to a workspace, so it will use your configuration in the workspace as well. So whenever you make a commit or anything like that, it will be under your commit.
What about for all the providers? Let's say I need to connect to a Kubernetes cluster from inside of the DevPods. Does that be done?
Yeah, you just need to put your kube config, right? Yeah. So as we see, this is here, and with it a Python. So then if we want to run this, we can, but we don't have time. So just to summarize, we can talk more later on, but to summarize, Depod just manages your infra so that you can have your workspace anywhere you want to. You can save costs because you can just switch off your workspaces when that is not required. And the most important part we are focusing on is like self-servicing capabilities. Like your researchers, your engineers can have a workspace whenever they want without all those infra management. Last is try Depod out. A lot of people are trying Depod out. I found a couple of tweets last night. There might be more, but I need to Google them. So to minimize their tool and libraries installed locally, clean their machines, as well as focusing on how they can use on more public cloud. Last is QA is done. There's a Slack if you want to join for more questions. And I've kept a lot of stickers at the end, so when you are leaving the room, just feel free to pull your stickers. And yeah, if no longer more, any questions, anything? We have 3 minutes more.
We don't have time for more
Wait,
questions.
don't have
But
time.
you can ask him anytime you want, like
Yeah.
after this.
This is my socials, if you want to connect.